Good morning, students. Today we will continue the relations. So the next problem, show that the relation R in the set A of points in a plane given by R equal to P comma Q, distance of the point P from origin is same as the distance of the point Q from the origin, is an equivalence relation. Further, show that set of all points related to point P not equal to 0, 0 is the circle passing through the origin as a center. This is the question. First we have to prove that equivalence relation. Equivalence relation, you know that already. We have to prove reflexive, symmetric and transitive. Okay? And these three conditions are satisfied, then the relation R is equivalence relation. Then one more further, the set of all points related to a point P is the circle passing through P with the origin as a center. You should take one more point on the circle, that point is related to P. Then distance also same, distance from origin. For example, okay, I will explain that. First you have to prove equivalence relation. Now what is the relation R equal to P comma Q such that OP equal to O? But PQ belongs to set A only, okay? But what is the set here? A set, okay? Then you start first one, reflexive. Problem is very simple, okay? Reflexive. For A belongs to set A. Don't take the relation. This element is there. This element belongs to set A. So always just P belongs to A. OP equal to OP. That is P comma P belongs to R. Therefore, R is a reflection on E. Very simple. But last period I told you that problems are quite simple, that students are confused, that the way of writing. So reflection. Directly OP equal to OP they are taking. OP equal to OP means what is a P? For P belongs to set A, not only P, you take any element. I am taking P belongs to A and OP equal to OP, even Q, OQ equal to OK. So OP equal to OP, P comma P belongs to R. So R is reflexive R. Second one, symmetric. Symmetric. So how many elements? You have to select two elements. I am taking P comma Q belongs to set A. P comma Q belongs to R. If P comma Q belongs to R, it implies OP equal to OQ. It implies OQ equal to OP. So Q comma P belongs to R. Therefore, R is symmetric. R is symmetric on a very simple. In a symmetric, I am telling two elements, so one order pair is given. two elements P comma Q belongs to set A. What is the given here? P comma Q belongs to R. We have to prove Q comma P. So P comma Q belongs to R means what is the condition? OP equal to OP. So we get it. And P comma Q belongs to OP equal to OP means your OQ equal to OP. No problem. Distance from origin. OQ equal to OP. OQ equal to OP means U comma Q belongs to R. Therefore, R is symmetric. Then what is the transitive relation? Transitive relation, transitivity or transitive relation. How many elements? 3 elements. P, Q, even you take S belongs to set A. There are 3 points on the set A. It is a circle only. There are 3 points on the circle. If P comma Q belongs to R, how many ordered pairs are given? 2 ordered pairs. And Q comma S belongs to R. In symmetric, 1 ordered pair is given, but in transitive, how many ordered pairs are given? 2 ordered pairs, A comma B and B comma C. So P comma Q belongs to R, Q comma S belongs to R. It implies OQ equal to OQ and OQ equal to OS. OP equal to OQ, OQ equal to OS. It implies OP equal to OS. That is P comma S belongs to R. Therefore, R is transitive. R is transitive on A. Hence, R is an equivalence relation on A. Very simple. Problem is not difficult. So it's very simple. So way of writing starting problem. So I am telling some students of PQRS belongs to R only, that is. No, these are set A. So how many ordered pairs? 2 ordered pairs are given. If P comma Q belongs to R, Q comma S belongs to R, OP equal to OQ and OQ equal to OS. So automatically OP equal to S, because this is the circle. This is center, this is a P, this is the Q, this is a S. OP equal to OQ. OP equal to OQ, OQ equal to OS, and automatically OP equal to OS, because the constant distance, the radius will be same. Distance from whatever the distance from P is same as distance from S. So OP equal to OS. When transition reflexive means OP equal to OP only. Symmetrical OP equal to OQ, OQ equal to OP. Transitive OP equal to OQ, OQ equal to OS, then OP equal to OS. Hence the relation R is an equivalence relation. That one more, the question, what is the question? Is related to. You take one element, the next part, further we have to prove. Let T belongs to set A. Next part. Now it is equivalence relation is over. So further one more question is there. Okay. But other than PQR you should take. But already P, Q and R. But you take any other than this. These three. T belongs to A. What is T? You know? T is but this T is related to P, and T is related to P. T belongs to set A. But you know what is the T? T is the related to P. When T is related to P means what? That is T comma P belongs to R. When T is related to P, T comma P belongs to R. When T comma P belongs to R means what? OT equal to OP according to the condition that just a relation is defined. So T comma P belongs to R means OT equal to OP. Distance from origin to the point T is equal to distance from origin. Where here O is what? No, O is the origin. Then what? Therefore, T lies on the circle. And before I am not telling where it is T and T outside the circle or inside the circle, on the circle, you do no. But here you know that what is where it is T. T on the circle only, same circle. T not outside the inside. T is also lies on the same circle. T lies on the circle. T lies on the circle. Passes through the point P, but P not equal to 0, T lies on the circle which passes through the point P, 0 with the origin as center. I will repeat once again, but it is very difficult, not easy only, okay? When asking sometime it is 5 marks question, so up to equivalence relation 3 marks, now it is 2 marks question. Students directly OT equal to OP, so this is wrong only. So T belongs to A, what is the T? T is related to P. When T is related to means what is the order P? T comma P belongs to R. And T comma P belongs to R, OT equal to OP. OT equal to OP means what? Distance from point. Distance, these two are distance are same only. When these two are distance from origin to the point, distance from origin to the, these two are length are same, but these two length are same means where is the T? T also on the same circle. So T lies on the same circle which passes through the point P, so with the origin as a center. This is the relation problem. Okay. Almost the problems I have solved. This is the video number 5. Okay. Next question I'll start. Give an example. Give an example of a relation. Give an example of a relation which is symmetric, but neither reflexive nor transitive. Reflexive nor transitive. Very simple. So it is a very difficult question. Example means it is very difficult. Give an example of a relation which is symmetric but neither reflexive nor transitive. So even before this, the previous videos, I explain many examples, parallel, congruent, similar, perpendicular, many types of problems I explained. So, parallel always equals relation. Parallel is always reflexive, symmetric, transitive. Congruent is all the three conditions are satisfied. Similar also all the three conditions are satisfied. Perpendicular I have not explained. In perpendicular, reflexive is not satisfied. Transitive is not satisfied. Only was symmetric. So this problem is asking symmetric but neither reflexive nor transitive. But here I will explain in generally, but you should try to hold in with set A you have to write. Without set examples I am giving. So if you want to practice, more practice, you take any set, 1, 2, 3, then you have to write no reflexive, no transitive, only symmetric. Okay? That is also correct. Nowadays, relation R is perpendicular. Yes. Over. Relation R is perpendicular. That is R x comma y such that x perpendicular to y is relation R is perpendicular to R is x comma y such that x perpendicular to y. Then definitely it is one mass question. Otherwise, examine the relation which is symmetric but neither reflexive nor transitive. You should say all the three conditions you have to prove. But here not necessarily. One mass question is there. Give an example. Give an example. Relation R is perpendicular to, that is R is x comma y, x perpendicular to y. So very important. But you don't write, only one word you have to write. Relation R is perpendicular is always reflexive, is symmetric, but not neither reflexive nor transitive. Only one word sent, because mass is one only. So if it is three mass question is there, so we are asking all the three. Examine whether the relation R is symmetric, but neither reflexive. Three mass question. But here one mass question, only the word answer. What is the word answer? Relation R is perpendicular to is, which is symmetric but neither reflection or transitive. Okay? Because the perpendicular line itself is not perpendicular reflection. In parallel line itself is parallel, but perpendicular itself is not. No reflection. L1 is not perpendicular to L1. Okay? But L1 is perpendicular to L2. L1 is perpendicular. This is L1 and this is L2. L1 is perpendicular to L2. L1 is this is L1, this is L2. L1 is perpendicular to L2, L2 is perpendicular to L1. When three lines are there, so automatically L1 is perpendicular, L2 is comes. L2 is perpendicular to L3, but L1, L3 not perpendicular, that would be parallel only. So good example. So you remember by the students, give an example of symmetry but not transitive and not reflexive. Okay. Next question. Give an example of relation which is reflexive and symmetric. No, sorry, it's transitive, but neither but neither reflexive nor symmetric. Give an example of a relation which is transitive but neither reflexive nor symmetric. What is the question? Which one is the transitive relation but no reflexive, no symmetric? Okay. Even this problems also explained in the previous class. Transitive relation, no reflection, no symmetry, where I think it should be greater than or less than, both are correct. X greater than y. Suppose x greater than y. So in this condition, greater than, R is a relation is greater than, is transitive but neither reflexive nor symmetric. Even if you want to write one sentence, x greater than x is not true, x comma x not belongs to R, yes, then the relation R is not a relation. Even you want x greater than y, and but y does not greater than x. The x comma y belongs to R, but y comma x does not belong to R. Okay, so x greater than y and y greater than z, it implies x greater than z. Even you can take example, no problem. Even this, you have to write. Even what I am telling depends upon marks. This is not 3 marks, but I am telling 1 marks question. 1 marks means only one word. Although some students are not satisfying, so how will they give the marks? But x greater than x is not x comma x not belongs to R. X greater than y, but y does not is x greater than y and y greater than z. X greater than z. This is inequality property. So automatically, so 1 greater, 2 greater than 3 and 3 greater than 4. Okay, this is correct. 2 greater than 3. I think 2 greater than 3. 2 greater than 1. Okay, 1 greater than 1 by 2. So automatically 2 greater than 1 by 2. But it's okay. So what is the answer? One word answer. What is the answer? Relation R is greater than. Relation R is greater than. Okay, is transitive. That is R equal to x comma y, so that x greater than y is an transitive but neither reflexive nor symmetric. This also is an example. What is the one more type example? You take consider set A is 1, 2, 3, 4 and no reflexive, no symmetry, then only what? Transitive. Okay? This also. Then the third problem. Then 2 problems over. Give an example of a relation which is, third problem, reflexive and symmetric. Reflexive and symmetric. Reflexive and symmetric, but not transitive. not transitive. But not transitive. But not transitive. This is very simple. This also, what is the condition? Two conditions must be satisfied. One reflexive, symmetric, but not transitive. But I am explaining only that general standard example. But if you want, you take one set and you have to, and you should try to practice that reflexive, symmetric and transitive. Okay? So here very simple relation R is, the relation R is X is a friend of Y. X is a relation R, the relation R is friend of, that is R equal to X comma Y, such that X is friend of Y. Yes, enough. Give an example of reflexive and symmetric, but not transitive. So definitely it comes reflexive and symmetric, because X is a friend of X. Friend itself is friend. X is a friend of X. It's always reflexive. X is a friend of Y. Y is a friend of X. It is symmetric. But X is friend of Y. X is friend of Y. X is friend of Y. Y is friend of Z. Not X is friend of Z. Maybe sometime. No friend. Is not a friend sometimes. Okay? X is friend of Y. Y is a friend of Z. But X is not a friend of Y. So this is the example of reflexive, symmetric, but not transitive. Followed or not? Tell me, X is a friend of X? Yes, friend itself is friend. X is a friend of X. X is friend of Y. Y is a friend of X. But X is friend of Y. Y friend of Z, but not X is friend of Z. Okay, this is the third example. What is the example? R, relation R is a friend. Is a friend. Is a friend of. Next, give an example of relation which is reflexive and transitive. Reflexive and transitive, but not symmetric. Very simple. Give an example of relation which is reflexive and transitive. Reflexive, transitive, but not symmetric. Solution: reflexive and transitive must be satisfied, but symmetric is not. Mostly this problem, my question, x greater than y. X greater than y is it reflexive? No, this is not reflexive, because x greater than x is not. Sometimes it is equal, yes. X greater than or equal. X greater than or equal, then definitely it is called reflexive. Only greater than, this is not reflexive. Be carefully, okay? Greater than or equal. Greater than or equal, it is 100% reflexive. Okay? So this condition is given. This even this is x greater, only greater than 1. Greater than means what is? No reflexive, no symmetric, and it must be transitive. Only greater than condition, only one condition is satisfied, that is called transitive. When greater than or equal and reflexive is satisfied, transitive is satisfied, but not symmetric. So what is the generally relation R is greater than or equal, is greater than or equal, that is R equal to x comma y, such that x greater than or. So this relation is called reflexive, transitive, but not symmetric. So repeating once again, and depends upon mass. So if it is 3 mass means you have to write all the 3's. Why it is not reflexive? Reflexive means how to show that reflexive. One x belongs to set A, x greater than x comma x belongs to R. x1, suppose set A is set A, x belongs to set x greater than x. So this is called reflexive. Transitive, how to show? Then transitive, there are 3 elements will be there, then 2 ordered pairs. Transitive also said, no symmetric. Okay. So symmetric means what? X greater than y, but y does not greater than x. X greater than y, but y does not greater than x. So this is the no transitive, no symmetric, but it is reflexive and transitive, but not. You remove that equal sign. Only one condition satisfied, that is called transitive. Okay. This also good example. So I explained, given example of relation. How many problems I explained? No? There are 4 problems. 4 problems. What I explained, at least you have to remember the problem. So what is the first problem? Perpendicular. Perpendicular means that you have to think that perpendicular means reflexive, no symmetric, and no transitive. In perpendicular only symmetric. And the second example, what I have given? X greater than y I have given. Greater than answer. What is the fourth problem? Find. In find, which conditions are satisfied? When question, x is a friend of x? Yes, reflexive. X is a friend of y? Y is a friend of x? Yes. So, transitive is not satisfied, is a friend. But same question, brother. A brother problem, x is brother of x. No. Brother, this also said, is a brother of. Brother of means no brother itself is not brother. Okay. No reflexive. No reflexive. No reflexive because x is not a brother of x. But x is friend of x. But x is not brother of x. Is it symmetric? X is brother of y. Y is a brother of x. Yes. This is also correct. Now what is the transitive? X is brother of y. Y is a brother of. So this is x comma x does not belongs to R. Okay. So x comma y belongs to R. It implies y comma x belongs to R. So x is brother of y. So y is the brother of x. So transitive x comma y. X is brother of y. Okay. And y is the brother of Z belongs to. So automatically X is brother of Z. So this is also satisfied. So what is the question? Give an example of relation which is symmetric and transitive but not reflexive. Okay? So I explained that 5 examples. Okay? So what are the name of the relations, the examples? One is perpendicular, one is greater than. But you have to, at least you should remember that problem statement. Then automatically, suppose perpendicular I am telling. Perpendicular what I am telling, suddenly you will get ideas. No? So perpendicular means no reflexive, symmetric and no transitive. So this problem, how do they will ask the question in example? One must give an example of symmetric, neither reflexive nor a transitive. That's all. Suppose greater than. So when x greater than y, you are remembered, no? So x greater than y means automatically you know that which one is satisfied, which one is not. Greater means x greater than x, no reflexive. X greater than y, y greater, no. That's only what transitive is satisfied. So how to write that example? Give an example of transitive, but neither reflexive nor. This is a very important example side one. These 5 problems you are expecting, but where you are expecting, just only 1 marks question. Be careful, these are very important. Well, 3 marks, 5 marks you have. So that is no problem. They definitely answers steps you get. Very difficult to 1 marks. 1 marks is very important. So we want 100 marks. So 1 marks is very important. So examples, even these 5 examples I give, you should try with the set. Set A, you have to write 1, 2, 3. All the 5 examples you have to try. When you are writing the examples you own, definitely you are perfect at relation. You are not giving example of reflections, you are not perfect. Okay? When you are perfect the relations chapter, you have to write the examples of reflexive, symmetric and what? Transitive. Okay, anyhow, so today's one is that previous one problems that are important. Here 5 problems I explained, that 1 marks question, examples, okay, given examples. So next problem, if R1 and R2, if R1 and R2 are equivalence relations, if R1 and R2 are equivalence relations in a set A, if R1 and R2 are equivalence relations in a set A, show that R1 intersection R2 is also an equivalence relation. Yes. Very, very important question. R1 and R2 are equivalence relations on a set A. Show that intersection is always equivalence relation. But this sometimes in CET the question asking R1 and when 2 equivalence relations, intersection is always equivalence relation. But union is not equivalence, only intersection. So interesting problem. So what is the, how to start? So roughly I am explaining. When R1 and R2 are equivalence relation means R1 is equivalence relation, R2 is also equivalence relation. These two are equivalence relations. When these two are equivalence relations means reflexive is satisfied, symmetric is satisfied, transitive is satisfied. Here also reflexive, transitive, when R1 is equivalence relations, these three conditions are satisfied. You know this one, A comma B, B comma A comma B, B comma C, A comma C. So all three are satisfied. R1 is equivalence means it is always satisfied, reflexive, symmetric and transitive. Here R2 is also equivalence, here also reflexive, symmetric, transitive. So both R1 and R2 equivalence relation, we have to prove intersection. We have to prove intersection is an equivalence relation. When equivalence relation, you have to prove again reflexive, symmetric and transitive. R1 intersection R2, we have to prove reflexive, symmetric and transitive. Okay? So it is very simple. So writing is very important. Okay? So we have to prove intersection is equivalence relation. Now let's start. Okay? Since R1 and R2 are equivalence relations on a set A, we have to prove that R1 intersection R2 is an equivalence relation. We have to prove that intersection of two equivalence relation is again equivalence relation. Okay? Then what is the first one? I'll start reflexive. Be carefully. Okay? Reflexive. So reflexive, how many elements you are choosing? Only one element. So what you prove here? A comma A. Okay? But here two equivalence relations are there, R1 and R. Reflexive means for I am taking one element in a set A. This element A belongs to A. Okay? So A comma A belongs to R1 and A comma A belongs to R2. Why? A belongs to A means A comma A belongs to R1, A comma A belongs to R1. Why you are taking A comma A belongs to A comma? Because R1 and R2 are equivalence relations. Because R1 and R2 are equivalence relations. For A belongs to set A comma A belongs to R1 and A comma A belongs to R1. Why are you taking this A comma A belongs to R1, A comma A belongs to R1? Because R1 and R2 both are equivalence relation. Equivalence relations I told you, reflexive, symmetric and transitive. Okay, reflexive. This is a reflexive. This is R1. This is R2. So this is a reflexive relation R1. This is a reflexive relation R2. Okay. So one element you have to choose. This our A comma A belongs to R1 and A comma A belongs to R2. It implies A comma A belongs to R1 intersection R2. Therefore, R1 intersection R2 is reflexive. This is reflexive on what? A. Very simple. Very, very simple. But simple is there, but even difficult steps also there. For A, if it belongs to R1, some student A comma A belongs to R1 intersection R2. When taking A belongs to A, R1, A comma A belongs to R1. Now we have to prove a R1 intersection R2. But A belongs to A. This is a reflexive. This is also reflexive. This is R1, R2. This are both are common elements. A comma A belongs to R1 intersection R2. Therefore, intersection is always reflexive. Then what is the next? Then second one is symmetric. Symmetric means what? How many elements? There are two elements. For A comma B belongs to set A. Okay. If A comma B belongs to R1 and there are two elements for A comma B belongs to A. So what is the given, A comma B belongs to R1 intersection R2. We have to prove B comma A. If A comma B belongs to R1 intersection R2, we have to prove B comma A. So it implies A comma B belongs to R1 and A comma B belongs to R2, because you should select one order pair A comma B, but in intersection you have to select one order pair A comma B. So reverse also must be intersection, but A comma B belongs to R, A comma B belongs to R2. It implies B comma A belongs to R1 and B comma A belongs to R2. Why are you taking A comma B belongs to B comma? Because R1 and R2 are equivalence relations. R1 and R2 are equivalence relation. Equivalence means all the three are satisfied. A B को B A लिख सकते हैं, कई को लिख सकते हैं R1 equivalence relation है, A comma B belongs to B comma A belongs, because R2 is also equivalence relation. 100% दोनों लिख सकते हैं. ये दोनों R1 R2 equivalence already है, but फिर भी B comma A लिख सकते हैं. With the B comma B लिख सकते हैं. So this implies B comma A belongs to R1 intersection R. Therefore, R1 intersection R2 is symmetric. Is symmetric on A. So interesting problem. This is symmetric. So repeating once again, you have to select two elements. A comma B belongs to A, not R1 R2. Already there is equivalence relation, but our aim had to intersection. So this order pair belongs to intersection. This is belongs to R1 and R2. If the intersection is there, so A B B A, because R1 is reflection, B is R2 is reflection. So B comma A belongs to. Now you are taking A comma B, here B comma A. So intersection always symmetric relation. Okay. Then what is the next? Third one, last one is transitive. Transitive relation. In transitive relation, how many elements you are choosing? 3 elements. Yes, very good. 3 elements. You have to choose 3 elements. So how many order pairs are given? 2 order pairs are given. What are given? A comma B belongs to R1 intersection R2 and B comma C belongs to R1 intersection R2. Whatever the order pairs, you should take intersection only. R1, R2 already equivalence relation, but you take intersection, 1 or 2 order pairs you have to select in intersection, A comma B and what? B comma C. It implies, what is A comma B? A comma B belongs to R1 and A comma B belongs to R2. Okay, this is one. And B and B comma C belongs to R1 and B comma C belongs to R2. So I am taking intersection. No? This is A comma B belongs to R1, A comma B belongs to R2, B comma C belongs to R2, B comma C belongs to R1 and R2. Now I want A comma B, B comma C. What is your aim? Your aim is to count A comma C intersection. I want it. So better you take these to one side. These to one side. So what is this is? A comma B belongs to R1 and what is? B comma C belongs to R1. You have select one side. You should take relation R1. And what is the one more? A comma B belongs to R2 and B comma C belongs to R2. R1 one side, R2 one side. It implies, what is the transitive? A comma B, B comma C. So A comma C belongs to R. Why? Because R1 is equivalence relation. Why are you taking A comma B, A comma C? Because R1 is equivalence relation. And A comma B belongs to R2, B comma C. Here also transitive. A comma C belongs to R2. Why? Because R2 is equivalence relation. It implies A comma C in R1 A comma C not 2, then what is the answer? A comma C belongs to R1 intersection R2. Therefore, R1 intersection R2 is transitive. Is transitive on A. Hence, so repeating once again, reflexive, symmetric, and transitive. So repeating. So what is output? A comma B intersection, B comma C intersection. Here separate, you take separate. Here also you take R1 one separate, R2 one separate. Using transitive, yes, this A comma C belongs. So you remember where they should. When the given two equivalence relations, intersection always equivalence relation. And next video, I am sure that whether union is equivalence relation. I am telling union of two equivalence relation is not equivalence relation. When given R1 R2 equivalence relation, union is not equivalence relation. Next video, I will, no proof is there, only examples I will give. Okay, how to prove that union is not a equivalence relation? Only example lesson, and almost is over. Even tomorrow, next video, only one or two problems are there. Even next video will start functions also. Okay, thank you.